All right, in this question, Charlotte created the quadratic equation y equals x minus 3 times x plus 5 in intercept form, which is y equals a times quantity x minus p times quantity x minus q. Now, p and q are your x-intercepts. That's why we call this intercept form. They tell you your x-intercepts of the quadratic. And now it says to model the height in feet of a ball over time. So it's basically y is the height of the ball, and then x is the time that's passed since the ball was thrown or launched into the air. Now, it says select the statements that are true based on the quadratic and context. First thing you want to do is maybe sketch out this graph. So I'm going to do that for you here. So I have my coordinate grid here, I have an x, I have a y. Now it says that the x-intercepts are 3 and negative 5. Now how did I get those? Just match them up. P is 3, so that's a positive 3. I'm going to put a dot here. That's 3 comma 0. The other one is negative 5. Now you might say, well, it says positive 5 though, but the form tells us it should be x minus q. Okay, the form is supposed to be x minus q. Instead, we have x plus 5. So we convert that to x minus, like we want the form to be, and then you just change that plus 5 to actually a negative 5, because when you have minus a negative, it becomes plus. So these two are equivalent. Okay, these are the same, but now you can see it matches the form I want, and I pull out that q, which is just negative 5. So in this case, maybe it's further down here, negative 5 comma 0. Those are my x-intercepts. Okay, the last thing you know about this quadratic from its form is that a can tell you the concavity. Just like in standard form, a can tell you the concavity of the graph. Well, there's no number here in front of the parentheses, so you can assume it's a 1. Okay, say it's 1. And that means it's positive 1. I have a concave up graph. It might look something like that. Okay, so let's go ahead and read the answers and see what might fit that. A, the ball will be at ground level after 3 seconds. Well, yeah, ground level in this case is just the x-axis. So after 3 seconds, where x equals 3, it's back at a height of 0. So that's true. B, the ball will be at ground level after 5 seconds. That's not true. 5 seconds would be over here somewhere, and you can see it's way up in the air at that point, crossing that out. The ball will reach its minimum height after 3 seconds. So it's going to reach its lowest point on the graph after 3 seconds. That's not true, right? It's just kind of at the middle here. It's not. It actually goes lower down to this vertex. That's not true. And then D, the ball will reach its minimum height after 5 seconds. Same thing. After 5 seconds, it's way up high in the air. So that's not true as well. The only answer here is A.